Hey everybody, what's up? And welcome to the first episode of Build Onchain. I'm joined by Eda from Hyperlane, who's a developer advocate for Hyperlane, and we're going to be talking today about Hyperlane's Warp Routes system. Eda, do you want to introduce yourself?
Yeah, thank you. Thank you for having me. So my name is Eda, and I'm a developer advocate here at Hyperlane. So we're going to be talking all about warp routes, which is Hyperlane's flavor of token bridging. And yeah, without further ado, I think I'll hand it off to you since we have like a demo and a presentation queued up.
Okay, awesome. So the first thing I'd love to ask, just for anyone who's like new or doesn't know what Hyperlane is, can you tell me a little bit about Hyperlane and the problem it solves? Like, what's Hyperlane? Why does it exist? And what do developers use it for?
Yeah, for sure. So Hyperlane is a general message passing protocol, and we have some applications which developers can use out of the box. So what this means is that when a developer comes in and is like, "Hey, like I'm stuck on one chain, I want to move my assets across, or I want to send a message," you can kind of use like the warp routes we have to directly like transfer your assets or like send messages across chains. So I will give like a short intro on why it's necessary in the Ethereum world or like in the general blockchain world we have today. So I'm not sure if maybe like we can start off with a presentation where I have some graphics to explain as well. So that might be a bit more helpful if I can go there.
Yeah, let's do it. That sounds great.
Awesome. So, okay. So to answer your question a bit more, to go back, today we live in a multi-chain world. What this means is that with Ethereum, we saw, it's Ethereum came up, it's great, okay, but like a few years down, it was not scalable. And then with the roll-up centric roadmap, we scaled Ethereum to a state where now it's usable. But what we have now is all these different networks, and we have like a multi-chain world. They're all like fragmented and not directly communicating with each other. And so today, the interoperability between rollups is sparse and highly fragmented. And what this means for both users and developers is that they're often limited to the network that they choose to. So you can see over here in the images, like a user usually has to like switch networks on their app. They're like, oh, I have like this game on like I have this game on base, but I want to play this game on OP mainnets. You kind of need to make that transition yourself as a user, or often you're like, okay, I can only actually do this action on base. So that like really limits both developers and users' potential. And yeah, that is actually not very fine to have. That's not like an ideal scenario when we are working with, when we are in Ethereum, you kind of want to make that transition and that UX easy for developers. And that is exactly where permissionless cross-chain interoperability comes in, and where we will be also talking about Hyperlane. So I know that's a mouthful, so I will kind of like deep dive into what like all these kind of permissionless cross-chain interoperability means. But to simply put it, is Hyperlane is a permissionless interoperability protocol for cross-chain communication with modular security. So I did add that modular security over here. It's not in the slides. And basically what you're doing is, let's say you have a new chain, you can kind of connect it yourself or to run your own infrastructure to connect to all these other networks, right? Like we said, like today, Ethereum is in a multi-chain system where you have all these different networks which don't communicate with each other by default. So you want a way to be like, hey, like I have like a new network, how can I connect it to this broader ecosystem? So you need like permissionless deployment where you don't have to actually ask for permission, but you can kind of do that yourself and connect your chain, or you can transfer your assets directly without having to need approval, because that's kind of like the whole premise of like building in the decentralized blockchain space as well, where you can kind of build it yourself in a decentralized manner without having to ask for permission. And simplified cross-chain communication, what this means simply is that you have some common building blocks to move assets and data between chains. So when you look at all these different networks, they kind of have to build their own infrastructure and assets themselves. Well, not just assets, but like all the infrastructure themselves to communicate with a broader ecosystem. And that creates like a huge friction point because everyone is building the same systems with not like a consistent format. So then you can kind of replicate and repeat. And where the point of modular security comes in is that you have the opportunity with Hyperlane to choose your security preferences according to your app's needs. So we have a system with, well, we have an infrastructure which uses ISMs called intersecurity modules, which are basically these plug and play modules where you can customize your security. So you can say, hey, like I want like a multi-sig security module, or like, hey, I want like a ZK security module, and you can customize that according to your risk tolerance. And that's a mouthful, and that's very high level. So let me share a small diagram. I know that the audience is mostly technical as well. And also, Christian, feel free to like be like, hey, can you explain, double click over here? More than happy to like double click on anything I talk about today. But to look at the high level overview is that the way Hyperlane works is that you have, or in general, interoperability works is that you have these different networks, you have like your origin chain, and then you have your destination chain. We have what is called Hyperlane mailboxes, which is your entry contracts into these each of these chains. So these mailboxes are kind of like your API into these different networks, which you can be like, hey, like I want to talk to, let's say your urgent chain is base or OP mainnet, and you can directly send a message to that mailbox over there. And then the way the message is carried is through an off-chain agent called the relayer, which carries the messages between the mailboxes, so then it reaches the recipient. How interchain security modules, which is the modular security building block I mentioned, fits in, is that you have those modules implemented on the destination chain where you're like, hey, like I want to make sure every message that comes into here is actually from the origin chain. So that is kind of how the modular security element fits in as well. And don't worry, we'll actually like be using Warp Routes today, and I'll do like a live demo of how you can have a Hyperlane token bridge, aka Warp Routes. So hopefully that will make it a bit more concrete as well.
Yeah, and I can just like step in here. Like I've used Hyperlane extensively as a developer and as a product manager. And one of the coolest things about Hyperlane is that there is this flexible interchain security module thing you talked about, right? So if I want to secure a really, a message, let's say that like is securing very little value, like a cross-chain intent, if it's $10, I could just use Hyperlane's default ISM, which is like already very secure, hasn't been compromised. And then let's say I'm like relaying a protocol governance update that's going to move billions of dollars in a treasury. Well, I can actually compose the Hyperlane default ISM with maybe like a security council multisig and some other sort of ISM, maybe like a ZK state root proof system, like Polyhedra, I think is one example. And that's super powerful, right? Because I can have a single message bridge that I have to interact with. But on the other end, I can have like multiple verification methods depending on the severity or consequence in the case that ISM was compromised. And that like flexible security assumption makes it really easy to design systems that secure like various tiers of value.
Exactly. So completely up to like your apps and needs. Very like changeable, like it's kind of like the plug and play modules. So just to like echo what you said, you can totally like use the existing ISMs or create your own if you're like, hey, I want to especially use this, which is not ready at the moment. Okay, so with that, we can actually move towards Hyperlane Warp Routes. As I mentioned a few times, Warp Routes are Hyperlane's flavor of token bridging. Now, they are also, as with the ISMs, they're quite modular. So you don't have to, you can kind of specify the warp route according to your token and which token you're bridging and how you kind of want to have that route. So what we will do in this demo is that we will use a token that is already on base. So that will be our collateral token. It's already like an ERC deployed to base and used over there. And we want to have that token available on OP mainnet. So we're going to create like a collateral to synthetic route from base to OP mainnet. And just to echo that, there are different flavors of warp routes according to your needs. I think this is like one of the most used, especially like, you know, a token generally lives on one chain and you want to have like a reflection of that on another chain. So that is the kind of warp route which we'll be creating. And Warp Routes build on Hyperlane's general message passing protocol. So you can see over here how the mailbox fits in. The reason why I'm like, we have Warp Routes and not just be like, hey, you can use like Hyperlane's GMP is because Warp Routes have like, they kind of make it easier for you to directly use the out-of-box Warp Route contracts instead of having to like build all these contracts yourself as well. Because
you just like for a second, do you mind explaining like what do you mean when you say GMP? Like what, I guess explain like what would a developer have to do using Hyperlane Space Protocol to design something like this, and like how does the route contract that exists in Hyperlane as like a template help developers do this super fast?
That's a great question. So the GMP, like the general message passing, for example, you have over here the mailboxes and how that communicates with the relayer, and then how that transmits back to the mailbox and then communicates with the ISM. So you have all these like building blocks already with Hyperlink general message passing protocol. Where warp routes come in is that you especially want to do this for a specific token. So you have like a token standard and ERC20. We also have like implementations for other token standards, but I guess like the most used is in ERC20. And you're like, hey, I especially want to like create like a way to transfer my ERC20 to another chain. In that case, you could write like your own contracts which kind of lock this token and then mint like a synthetic version on the other chain yourself as well. But what warp routes provide you is also these like hype ERC20 collateral and these EVM hype synthetic contracts that automatically allow you to be like, hey, I want to like directly use this Hyperlane's message passing protocol, which includes like the mailbox and how the mailbox communicates with the relayer, how you can input like the interchain security modules. But not just that, but I want to make it like super easy that this is my specific use case. It's like a very common use case where I want to transfer one asset that lives on a collateral chain to another chain. Is I want to already have like these warp route contracts as well. So it kind of adds like extra smart contracts when you make the deployment. So then you don't have to like build these token contracts that lock your tokens and mints a new one as well. If that
Yeah,
makes
and I
sense.
think that's like a huge, like a gigantic value that Hyperlane provides. Like having written contracts like this, you know, for you have to like figure out like how do I implement the base like mint and burn logic? How do I deal with the security of the underlying bridge? How do I deal with like drop transactions or like put deal with the edge cases I have to deal with, like bridging across chain? And it's like a pain in the butt. And then you have to get it audited, and the audits are super expensive. And like essentially, what Hyperlane is offering, like this is a very common use case, locking a token on one chain, minting the token on the other chain. And we have like audited contracts that allow you to just deploy this in like a second. And I'm sure you're about to demo like how quickly you can deploy one of these right now.
Exactly. I think like just a bit over a second, but that is a great way to explain. And I feel like, yeah, it's so you have the Hyperlane messaging available to you, but you kind of want to make it even faster because these use cases are super common and people often come to use these specific use cases. So as you said, like you don't want to like if you create like an audit for every single like new token which you're going to have on the synthetic chain, or like for if everyone does it themselves, it's just going to be like an extra burden. So this is kind of out of the box, ready to use way to implement token bridging.
Cool.
Okay, well, demo. So we're gonna do a live demo. I hope it works. I tested it just this morning, so I think it will work, but always Murphy's Law with live demos. So please bear with me. And I do have this, you can directly scan the QR code over here, or you can just go to like my Eda Akturk 14 Hyperlane Developer Workshop, follow the link over here to kind of see the steps. We're gonna be doing collateral to synthetic warp route using the Hyperlane CLI. And now I want to actually share my, oops, I think I lost you.
Oh, I can still hear you.
Okay, awesome. I'm just going to come here and share my screen. Oh, okay. I already have my full screen. Apologies for that. Let me present again because now I want to share my full screen.
Yeah, no worries.
I
And,
don't
and
have a
Dave,
mullet.
and Dave, if you need to cut here, we can totally just cut and go straight to this.
Okay, awesome. So this is the GitHub repo, which I was talking about, the Hyperlane Developer Workshop. I'm going to directly follow this workshop. But yeah, like there's like a small primer over here. And what we're building is we're going to build like a token, a Hyperlane warp route from base to OP mainnet. Our token on base, you can use any token. I just came over here to base. Like these are the tokens on base. And I'm going to use the Phi token, this AI token of this AI phrase agent. I will copy this contract, but this token exists on base at the moment. It actually exists on a few other chains. But what we want to do is, oops, not this one. But what we want is we want this to have a synthetic version on OP mainnet as well. And let's actually directly go to that. Let me open the docs to show where people can go and find the docs as well. I'm actually going to be following the very first like bridge a token quick start guide. Also, for more details on warp routes, like I explained, like very high level, you can come over here, you can see the details, you can see the chart over there, you can see how to use the interface and like more example of warp route combinations over here as well. So just to say, like, please do feel free to like head over to our docs afterwards, use this guide, yeah, without further ado, let me get to it. As a prerequisite, I already have the Hyperlane CLI installed, and I did add my private key for contract transaction signing. So that is done by like, I added like hype key to my terminal, just like over here. So that's kind of just easy for the demo. But you need this private key because we will be deploying contracts to both these chains. And you obviously need to pay for the gas cost for the deployment, and that is which account will be like paying for the deployments. And any primer knowledge I need to say, I think we covered the basics. One actually last thing, which I did not mention before, is that I talked about the Hyperlane mailboxes. So those mailboxes are your entry and exit into the different chains. So we have mailboxes deployed to over 150 chains, and they are all in the Hyperlane registry. Now, let's say you have like a chain which does not have a mailbox deployed. You can either deploy a mailbox yourself as well, but then you need to like add it when you do like a warp route, you need to make sure that you add it to the registry as well. Because I'm using like chains which already have mailboxes deployed, I will not be like using this chain configuration step. But just like an FYI, let's say like you launch like a new network which does not have Hyperlane already deployed to it. That is actually the initial step, is to have like a mailbox, which is, as I mentioned, your API entry exit into that network. Okay, cool. Let's get to it. So I have over here my terminal. I hope that this is big enough. Let me just make it a bit bigger. So what I'm going to do is I'm going to do a Hyperlane warp init. So I'm going to initialize a warp route.
And how are you specifying? Oh, there you go.
Exactly. So this will directly give me the, how do I say in English, like the automatic response. The command line will automatically ask for inputs from me. So I will select mainnet. A bit crazy to select mainnet. I'll select base, so it's base, I select base, and then as you can see, these are all the networks that are already in the Hyperlane registry.
Straight
So
up,
I'm not
never heard of some of these chains before.
Fair enough. So I'm just gonna scroll down to OP, optimism, enter, and then enter. So it asks like, is this correct? Yes. So I already specified this owner. If you had not, it would actually ask for you, but I just added my address already. So you can use, like, I will actually use, and let me show you where you can get this proxy admin contracts as well, but you can find them in the Hyperlane registry. I think I have them linked over here. Yeah, so you can go over here to the registry to find the proxy admin contracts. You can also find the ISM details, but you can just copy and paste them from here. You have the proxy admin contracts. For this demo, we can actually just skip this step since this is just like a working demo. But for all the networks, you have like your proxy admin and the default ISMs, which are specified in the Hyperlane registry. Just to make it faster, I'm gonna like quickly skip what is not necessary for the demo. And then you can specify like your trusted ISM, which again, you can find details all in the registry. And then for base, yes, base. Base is our token, which is a collateral token. We have the Frasa token, which is the FI one. And I will go over here. I'll select collateral. It will ask me for the address. Let me go back here to Frasa. I just copy this address. And then I will paste this here. The owner is the same. So yes. We will also skip for the optimism side. So on the optimism token side, we are going to choose a synthetic token. So this will like deploy the contract, which will allow us to like mint a new synthetic version of that base FI token. Okay, I click enter, it's automatically created. I can go actually over here to, oops, I can actually just, you can see over here the config, the YAML deployment has the details. And yeah, you can just see the token name. This is collateral, and then this is synthetic. The owner is as we specified. But just to let you know, like you also have this information here. Can I just make this bigger?
And
as
this
well
and this and this YAML is basically just automatically generated as part of the initiation process. If you were like in a more advanced developer, you could like modify this yourself and add everything you wanted to if you needed to.
Exactly. That is very correct. So this was not existing before. So this deployment, the Hyperlane Warp init, actually deployed the YAML, like created that file for us. Okay, so what we do next is now we need to deploy the contracts. But before deployment, I just want to make sure that we're not missing any steps. We initialize our warp routes. We talked about like synthetic and collateral tokens, and now we're just going to deploy. This is actually like the last step. So what we did was we did Hyperlane Warp init to initialize. We created this initial YAML file, and now we're going to do a Hyperlane Warp deploy. Now, because I already added my private key as an environmental variable, it will not ask me. But FYI, if you did not add it before, it will prompt you to input your private key because you need to pay for gases. And I have already like some tokens in both my Optimism and Base wallets to pay for the transactions. I'm just going to click no for the purpose of moving fast. It displays like all the details over here. I will click yes. Yeah, make sure that you do have the enough tokens. It will display the gas costs in the end. It's not going to cost me much to deploy all this, but you do need to make sure that you have enough funding in both the networks that you're deploying contracts to, because in this case we're deploying both the EVM synthetic and collateral contracts to Base and Optimism respectively.
Okay, that totally makes sense. So one other question, I guess, as you actually go to initialize this bridge, do you need to have the actual token that you're creating the synthetic bridge for at the time? Or is it okay that you pre-create it and then deposit later? Like sometimes when you create a pool, there's like there's like a initial first deposit.
Yeah, so we are just creating the contract. I have it already, but you don't have to, because when I want to mint the synthetic version, I need to make sure that I have enough collateral there. But yeah, like you can first add the collateral afterwards too. Like you don't need it during deployment, if that makes sense. Like if I directly have none phi tokens on Base, and then I go and I try to mint the synthetic version on OP mainnets, with I don't have any tokens locked in already, so then it won't be able to mint it, if that makes sense.
That totally makes sense. Oh, and there it is. It looks like it's already been deployed.
Exactly. So we have already deployed it. You have the gas statistics. So as you can see, quite like negligible cost. I have over here this printed out. A quick trick I can do is I can actually just come here and I can copy this. I'll just copy this. And then there is a Superbridge UI, Superbridge Playground UI, which you can interact with. I want to open this on a new tab. So we can actually test this out. So this is already built by the Superbridge team. It uses like a small UI. This is the playground version. So I come over here, I can do warp routes, I can customize, and I just copy paste this YAML, which was generated in our CLI. We save this. Okay, let's close this. And then as you can see, the phi token is now here.
How does it automatically get indexed by Superbridge?
So this is just like the playground version. So you can just customize it over here and you just add like your YAML configuration to say like, hey, this is the address and then this is the address. Like if I send, like you need to add the custom warp route over here. It doesn't automatically add it to their UI.
That makes sense. That makes tons of sense.
And then I need to connect my wallets. Let's connect my MetaMask I have here. I think I have some phi tokens, so we should be good. Okay, connect. OP mainnet, we're going to do from Base. You can see that I have like 189 phi tokens. I think that's like $2. Let's send like 10 to OP mainnet. Review bridge. I've already read all the disclaimers, but if you have not, I would suggest to first read the disclaimers. Approve. already approved. Let's start the transaction. You can view this on the Hyperlane Explorer. Oops, this is not loaded yet because the message is not indexed yet. But we can leave it on the base Explorer. As you can see, token of 10 to from this address to this address. You can see you can see all the details of the tokens and the transfer. And then let's actually also see the other one on OP mainnet. What else can we look here? We can look over here. Okay, this is the address I want to see. So this is my address, which is the signer, which created the warp route. As you can see, we actually deployed like the contract creation was like 3-4 minutes ago, where we deployed the contracts on base. So this address, which I have ending with 4D, deployed the contracts, which are like our warp route contracts. And then it actually transferred the token as well, because I'm using the same wallet.
Nice, super cool. And then I think probably, does the Hyperlane message show up, I think, now that it's been indexed on base?
Yes. So as you can see the transaction from base to optimism. You can see all the details from sender, message details, etc., how much you paid for gas. And basically we now have this token, like 10 Phi tokens of our synthetic token on OP mainnet.
Nice. That's super sick. That's super cool.
Yeah, well, I'm glad there was no errors with the demo. But yeah, it's actually quite straightforward. As you can see, it took us like 5 minutes, I guess, because we were talking as well, to deploy a token bridge from one collateral token to mint a synthetic version on the other. And then you can follow this guide to do the exact same thing. You can look more into warp routes and be like, hey, I want to like use another token like version instead of like a collateral token. You can use like a native token, a native to native route, for example. But you can find all those details in our documentation. Hopefully this was a helpful demo. I can stop sharing right now and come back here.
Yeah, I'll just ask a couple of questions just to keep us within time. I know that you have a hard stop. So first question, I guess, is just like what types of projects do you think are most primed to use warp routes?
Yeah, so I feel like every app that you build today on a single network is mostly limited to that network only. And especially when you're building crypto, I think that's like a huge limitation. So if you have like any asset on one chain and that just creates like a lot of, you can tap into so little potential on a single network, then where you can be like, hey, I want to extend and I want to make sure like this communicates with other networks, that it makes it easier for any kind of message passing, any kind of asset transfer. Really, I think most apps do need to build in the multi-chain world in order to actually be used.
Totally, that makes sense. And then I guess like if a developer wanted to deploy warp routes right now, where should they go? I think you have that like QR code, but is there anywhere else in the docs that they should go to see these tutorials?
The docs are a great place. You can find the first bridge. I can present as well to show exactly where you can find that. The docs are the best place to go to. Okay, I can see we also can add that to the description there. That's great. But let me share. Okay, I'm going to share my screen here. The docs are a great place to go to for any kind of information regarding how to deploy your warp route. You can see over here, we also have the SVM warp route guide or an EVM to SVM as well. But this was the standard quick start, which I followed. This is the one which I recommend to easily follow. As you can see, it was just like 5 minutes. You can read more about warp routes, or you can go over down here to more specialized use cases. And you can be like, I want to do like an XERC20 warp route, or I want to do like a multi-collateral warp route where you're like, hey, like my token is, I want to mint like a synthetic version of a token which is both on Optimism and Base, for example, like use 2 different collateral tokens.
That's
so
cool.
all these specialized use cases you can find over here as well. And yeah, I think the docs are a great place. We also have the Hyperlane Discord where you can jump in. There's a developers channel there for any questions you might have. And yeah, I think docs and Discord is the best place to keep up.
Okay, awesome. Well, thank you so much. This was sick. If you want to go and deploy a Hyperlane Warp Route right now, you know how to. And Eda, thank you so much for joining us for our first episode of Build on Chain.
Thank you. Thank you for having me.